Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the Algebra 2 Trig January 2016 Regents exam. All right, let's take a look at question 11. It says, in a circle with diameter of 24 centimeters and a central angle of 4 pi over 3 radians intercepts an arc. The length of the arc in centimeters is, in this problem, you need to remember the formula for the length of an arc. So we have S is equal to R theta. This is a formula for the length of an arc when theta is in radians. Theta in radians. If it were in degrees, we have to use a totally different formula. Okay? So what you have to be really careful about when solving problems like this is make sure that you're working with the correct measures. The diameter is provided here, so you do not input that into this formula. Okay? So the radius is diameter divided by 2. Okay? So we're going to divide 24 by 2. That gives us 12. That's the measure that we're going to be working with. Our angle in radians is 4 pi over 3. And S is what we're looking for. Okay, so we have all the ingredients we need to compute the arc length. So the arc length is going to be S equals R 12 times theta, which is 4 pi over 3. Okay, now let's go ahead and cross reduce. 3 goes here 1, 3 goes here 4 times. And then 4 times 4, you end up with 16 pi. Answer for number 11 is option number 3. All right, let's take a look at number 12. We have an absolute value inequality. So it says which graph is the solution to the inequality 4 times the absolute value of 2x plus 6 minus 5 is less than 27. Now, this problem, you can actually determine the correct answer just based on the look of the inequality. Anytime you have an absolute value inequality that's less than, so you have ax plus b less than c. In most cases, it's going to be a bounded region, okay, a sandwiched situation where you have 2 boundary points and then every point in between it. All right. So just based on the fact that we have less than, it's very likely that our answer should be option number 2. But of course, I'm going to go ahead and solve the problem just to make sure that our guess is actually correct. Okay. All right. So let's go ahead and solve this algebraically. So we have 4 times the absolute value of 2x plus 6 minus 5 is less than 27. So the goal is to get the absolute value quantity isolated first, and then we'll get x isolated after that. So let's work our way from outside inside. So add 5 to both sides. That yields 4 times the absolute value of 2x plus 6 as less than 27 plus 5 is 32. Divide both sides by 4. Divide by 4. Divide by 4. And then we have the absolute value of 2x plus 6 is less than 32 over 4, which is 8. Okay, now we're going to write this absolute value inequality as a compound inequality. Okay, anytime you have less than, you can write this as negative 8 less than 2x plus 6 less than 8. Okay. All right, so the next goal is to get x isolated. So we're going to be solving this compound inequality with 3 sides simultaneously. So we'll subtract 6 from all 3 sides. We'll do that. We have negative 14 is less than 2x, and 2x is less than positive 2. And then finally, to get x isolated in the center, we'll divide everything by 2. Okay, so we'll divide by 2, divide by 2, divide by 2. How we carry out that division? Negative 14 over 2, you have negative 7 as less than 2 divided by 2x, and that's less than 1. Okay, so if you want to graph this inequality, is a set of all numbers between negative 7 and 1. So if I want to graph it for you, just put negative 7 here, put the 1 here, open circle, and x is bounded in between that region. Okay, so as you can see, our guess was actually correct. Answer is option number 2. All right, let's take a look at question 13. It says, what is the sum of the roots of the equation of this quadratic right here? So let me show you one shortcut that you can use to find the sum of the roots of any quadratic equation. As long as it's in standard form, it's a shortcut. The sum of the roots is always going to be sum of roots. Is always going to be negative b over a. Okay, this is because when you add the quadratic formula, the radical components divide out, so you have double b over 2a, negative b over 2a, the 2's cancel out, and you have negative b over a, okay? So in this problem, as you can see, b is 6, a is negative 3. So when you compute negative b over a, you have negative 6 over negative 3, and the answer is 2. So our answer is option number 2. Okay, now let's say you do not know the shortcut or you've forgotten. How do you do it? Well, all you just have to do is go ahead and solve the problem, find the roots, and find the sum of the roots. Okay, that's what I'm going to be doing here. I'm going to show you the long way. Okay, just for insurance purposes, long way. No shortcuts here. Okay, so we have negative 3x squared plus 6x plus minus 2 is important. You know how to solve quadratics for the Regents exam, because this question might be altered. Okay, so I don't like the a being negative, so what I'm going to do first is multiply both sides of my equation by negative 1. Okay, just to flip the sign, so I'll have 3x squared minus 6x plus 2 equals 0. So the question is this a factorable quadratic equation, or is it prime? Well, let's test it with the x game. See if the two numbers that multiply to give you AC and add to give you B, then this would be a factorable quadratic. Okay, so AC is 6, B is negative 6. If you think about all the combinations of numbers that multiply to give you 6 integers, we have 1, 6, and 2, 3. Let's see. None of them can add to give you negative 6. Okay? So what does this mean? This means that this is prime. I cannot factor it. So does that mean I can still find the roots? The answer is yes. We're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So my roots are going to be negative, oh wait, let's see. Let's list what A, B, and C are first so we don't make mistakes when substituting. So A is 3, B is negative 6, and C is 2. Okay, so let's plug it into the quadratic formula. X equals negative b minus 6 plus or minus the square root of b squared, negative 6 squared, minus 4ac, 4 times 3 times 2. This entire thing divided by 2a. So that's divided by 2 times 2. No, 2 times 3. Okay. All right, let's go ahead and simplify it further. So we have x equals, times these together, you have 6 plus or minus the square root of 6 squared, negative 6 squared is positive 36. 4 times 3 is 12 times 2 is 24. Minus 24 over 6. So we can split it now. 6, well, let's just keep it together. So 6 plus or minus 36 minus 24 is 12, root 12 over 6. Okay, so we are going to be subtracting the two roots. Let me simplify it all the way, because in some problems you might actually have to find the roots. Okay, so we're going to have 6 over 6 plus or minus. If you break down 12, 12 is 2 root 3, 2 root 3 over 6. So our roots are going to be 1 plus or minus. You can divide 2 goes here 1, 2 goes here 3. Root 3 over 3. Okay, so let's find the sum. The sum is simply going to be 1 plus root 3 over 3, the positive 1, plus 1 minus root 3 over 3. So what you see happening here is that the radical components cancel out. You end up with 1 plus 1, which is 2. And that's what we got earlier with a shortcut. Answer is option number 2. All right, let's take a look at number 14. It says the scores of 1,000 students in a standardized test were normally distributed with a mean of 50 and a standard deviation of 5. What is the expected number of students who had scores greater than 60? All right, so on your reference sheet, you'll be provided with a normal curve for standard deviation, and that's what you're going to use for this problem. So what we want to do is we want to find out the percentage of the population that scored greater than 60. We have 1,000 students. This is a distribution based on percentages. We're going to be looking for the population of percentage of students that scored 60 or greater. Okay, so let's take a look at an equation. What I'm going to write is we have the mean. The mean, I can write this as the mean is 50, and then our standard deviation is 5. So the question is starting from 0, okay? Starting from the mean of 50, this is where it's positioned. The question is how many standard deviations will give us 60? Okay, how many standard deviations from the mean of 50 will give us 60? So think of it as though your mean is right in the center. Okay, mu is 50. So how many standard deviations? We're going up, right? Because 60 is greater than 50, right? How many standard deviations will take us to 60? One standard deviation is 5. 2 standard deviations is 10. So 10 plus 50 will give us 60. So 60 should be right here. This is what 60 is. Okay. So let me just do the same process algebraically. So what you have is we have 60, the targeted amount, is equal to the mean plus a certain number of deviations from that mean. Okay, so 60 is basically the mean, which is 50, plus a certain number of standard deviations times the deviation, which is 5. Okay, so we solve this equation. What you do is subtract 50 from both sides. Subtract 50, and then you have 5n, 5 times, the standard deviation times the number of standard deviations equal to 10. 60 minus 50 is 10, divide both sides by 5, and you have 2 standard deviations to take you to 60. Okay, so the question asks for the number of students who scored greater than 60. Okay, so what we're looking at is this percentage right here. This percentage right here. All right, so if we can determine the percentage of the population that resides above 2 standard deviations to the right of the mean, then we just multiply that by our total population. Okay, so let's go ahead and figure out the percentage of the population for students in this case, which is 1.7 plus 0.5 plus 0.1. Okay, if you add it all up with your calculator, you end up with 2.3%. Okay, so 2.3% of the entire population got 60 or greater. So let's figure out the number. Okay, so number of students, actual students, not just the percentage, will simply be the total, 1,000 multiplied by the percentage that fit this requirement, which is 2.3. Well, actually, 2.3%, we have to write this in decimal form. So we can write it as 2.3 over 100, or just move your decimal point 2 places to the right. 2.3% is 2.3 over 100. You can enter this into your calculator like that, or you can write this as 0.023. Move your decimal point forward twice. So 0.023. 0.023. So the exact number of students, you multiply this out, you end up with 23 as your final answer. Our answer is option number 2. All right, let's take a look at number 15. It says if t is equal to 10x squared over y, then log t is equivalent to. So this is testing your ability to make accurate application of the properties of logarithms. So we have t is equal to 10x squared over y. So log t is going to be, you just take logarithm of what t is equal to, right? So log of 10x squared over y. Okay. All right. So first of all, you want to remember that whenever you're dividing, is the same thing as subtracting the logarithmic arguments, and when you're multiplying, is the same thing as adding the logarithms of the factors that you're multiplying. Okay, so let's just write them down here. So log of a b is equal to log of a plus log of b. Okay, and then log of a over b is equal to log a minus log b. And then also if you have log x to the a, you can power this down as a log of x. All right. Okay, so let's apply that here. So we have log of, let's do the division first. 10x squared, the numerator, minus log of the denominator. Okay. Now, based on just the sign right here, we have a minus log y. We can eliminate options 3 and 4. It should be 1 or 2. That should be the correct answer. Okay, so let's decompose this further. We can write this as log of 10 times x squared. Okay, log of 10 times x squared minus log of y. So you have a product here, so we are going to express that as a sum of the logs of the factors. Okay, so we have log of 10 plus log of x squared minus log of y. Now, if there is no base for your logarithm, what is the default base? If there's no base, this is log base 10, okay? There's an imaginary 10 here, an imaginary 10 here, or you don't put it, okay? That's known as a common log. So you also have this property right here. If you have log base b of b to the a, this is just simply a, okay? So that's what we have right here. So this 10 has an exponent, which is 1. So if the logarithmic argument and the base match, they cancel each other out, and you're left with the power, okay? So this basically becomes 1, because these two cancel out, you're left with the power, 1 plus, and then you can use this property here to power down the exponent, the 2, so you have plus 2 log x minus log of y. Notice I took out the 10s because for common logarithms, you don't have to put the 10. Okay, answer is option number 1. 1 plus 2 log x minus log y. Thanks again for watching this presentation. Don't forget to Subscribe for updates to the remainder of this review series. If you have any questions, just ask your question in the comment section below. And don't forget to give us a thumbs up if you found the contents of this presentation beneficial to you. Thanks again for watching and have a wonderful day.